So for today we are going to discuss rotations. Now it's very important that with rotations you remember what it means. It means like a turn. When you're looking at a clock, the hands rotate around the clock. So here are the major parts of a clock. And let's say this is, the hand, they rotate. Now this is the clockwise direction. So this way is clockwise. Okay. So the other way would be counterclockwise. Make sure you know the difference because it does matter which way you rotate a figure. So going backwards from the larger number to the smaller numbers, or going backwards on a clock, is called counterclockwise. Okay, so the notation for rotation, that sounds like it rhymes, is a capital R. That means you're going to rotate. Now, I know we mentioned before it's possible for doing a reflection that they use a capital R. So the biggest difference here is that they'll give you a center in which they're rotating about. So in a clock, the center is right here, okay? And then they'll give you the degrees in which you will rotate it. That's how you could really tell the difference between a reflection and a rotation. A reflection will give you a line, as we learned earlier this week, and a rotation will give you the number of degrees. Now, if they don't give you a center, and they just write the degrees, this means that the center is the origin, or 0, 0 when you're on a graph. So if they don't give you the center, it is known that the center is the origin. So let me give you a little brief example of what that might look like. So let's say if I rotate, let's do 180 degrees, about point A. So here's point A, 180 degrees. So it would look something like this. And I would have a point here, and I would call point A. And let's do it to line segment BC. So here is line segment BC. So the idea here is we want to rotate it 180 degrees, meaning we want it on the complete opposite side of this point A. So B would have to be the same distance but 180 degrees. So this is 90, 180, or 90, 180. And then point C would be on the complete opposite side as well. So the nice part about having this iPad is I could show you the paths in which these 2 points will take. So look at this circle I just created. That is the path that point B can take because it has to stay the same distance away from point A. So B prime should be 180 degrees. So here's a 180 degree angle to the other side. So here's where B prime would end up after a 180 degree rotation. And now let me show you point C. So here is point C, and so in relative to the center, point C is about here. So 180 degrees would be on the other side of that right here. So here is where C prime is. And that is my image point after a 180 degree rotation. And it would look something like this. So if I get rid of these circles and these markings, you can kind of get an idea of what the rotation looks like. It ends up on the complete opposite side of this point, of the center point. So it's always about the center. And an important thing that you need to know is that if I give you a positive degree, you were to go counterclockwise. Now, when you go 180 degrees, it doesn't really matter because 180 degrees is on the other side. But if I'm going 90 degrees, it will matter which way I go because if I give you a negative degree, like negative 90, then you go clockwise. So it's important you remember the difference. And if you forget, the way that I remember counterclockwise is because if I think of a graph, I know this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So notice I actually labeled that in a counterclockwise direction. So a positive degree will go in the same direction as the quadrants. So if I start in quadrant 1 and I go 90 degrees, I will move 1 quadrant counterclockwise. If I go 180 degrees, I will go 2 quadrants counterclockwise. If I go 270 degrees, that means 3 quadrants counterclockwise. If I go negative 90, I have to go in the opposite direction of the quadrants, clockwise. So that's really how you could remember. That's really what you need to know about rotations. So here I have some patty paper. I just want to do a couple of examples of how to do a rotation. So if you see here, it says we want to rotate about point C. It's important that you really circle the center because the center won't move. It's like the center of a clock. It's as if I put my pen down on this and then I spin the figure around it. Now we want to go a positive 90 degrees. So that means everything needs to shift counterclockwise in this direction. So now I sometimes, if I could turn my paper, that's great. But if I can't turn my paper, this is what I do. I tell myself, okay, this is up, this is down, this is left, and this is right. So now why do I do that? Because everything will now shift in this direction. So everything will shift here. So if I say up, I really mean left. If I say left, I really mean down. And if I say right, I really mean up. And if I say down, I really mean right. So everything gets shifted only once, 90 degrees. Notice, I only went 90 degrees each time. So now, from point C, point C is not going to move because it's in the center. So actually, that's the easiest one to put. Here's my C prime. But if I want to go to A, originally, I'd have to go 1, 2, 3 spaces up. But now, we said up, if you look down here, up really means we have to go to the left. So let's go to the left 3 spaces. 1, 2, 3. So that means this point right here is my A prime. From A, I have to go to the right 2 spaces. See that right up here? From A, I have to go 1, 2 spaces to the right. But the word right now really means up. So that means I have to go up 1, 2 spaces. And this should be point B prime. And then I can finish connecting it. If I look, this triangle actually turned 90 degrees counterclockwise. Because positive means counterclockwise. And that's how you rotate an image. If this confuses you down here, you're more than welcome to just turn your paper. But I have trouble just turning my iPad because then if I do that, my orientation of my iPad will change. As you know, when you turn your phone sideways, everything shifts. So let's try this second question. This second question says Q is my center. So I'm going to circle Q because it's not going to move. So that means this point is going to be my Q prime. All right. Now, I like to always draw this. You don't have to, but I like to do this. Here's my up, my down, my left, and my right. Now, the cool thing about this number right here, so we have 180 degrees. So now, up really means down, and down really means up, and left really means right, and right really means left, because that's 180 degrees. Do you see I'm making a straight circle? We talked about a straight angle. We've talked about this before in our first week of lessons. So really it's just the opposite. Okay, so that means if point P is 1 to the left, P prime should be 1 to the right. So here's my P prime. Now, from point P, if I want to go to O, I have to go 1 to the left and 2 up. So I'm going to do the opposite. I should go 1 to the right and 2 down. Here's my point O prime. So I'm doing the opposite because it's 180 degrees. From point O, I need to go 1, 2, 3 down to N. So from O, I should go 1, 2, 3 up to N because I have to do the opposite. N prime. Then from N, I go 1 to the right to get to R. So I have to go 1 to the left to get to R. And then to complete this, I have to go 1 to the right and 1 up to get to Q. So 1 to the left and 1 down. So now I could just connect it. And it should look like I went 180 degrees, which it happened. Look, this is a full rotation of 180 degrees. So just see that difference. I mean, if this, again, confuses you, you could take your paper for 180 degrees, you could turn it completely upside down. So there's some more examples if you'd like some practice. I do want to skip down to some of the graph questions here. So let's just focus on triangle ABC. So triangle ABC is currently at 2, 6, and also at 5, 6, and at 1, 1. And I want to rotate about point O, so here's point O, the origin, 90 degrees. So that means I want to go 1 quadrant. So it should end up in the next quadrant. So if I need to use this right here from earlier, this is going to help me. So I'm actually just going to copy and paste it here, because this is what you do when you go 90 degrees counterclockwise. So let's start with A. So A is 2 to the right, 6 up. So 2 to the right means I'm really going to go 2 up. And then 6 up means I'm going to go 6 to the left. So instead of right and up, I need to go up and left. So I'm going to go up 2 and left 6. So here's my new A prime. So right, up, because remember, go to the right for X and up for Y. Shift it completely over means up and left. So my new point for A prime is -6, 2. For B, I have to go to the right 5 and up 6. So instead of right and up, I'm going to go up and left. So up 5 and left 6. So here is my B prime. And same thing with C, up and left. Here's my C prime. So here is my image. So there is my rotation of 90 degrees. I actually did not get a chance to finish writing these, but I just put them down. Okay. This is helpful, but turning your paper also works. But, if you're doing work on the computer, it's very hard to turn your computer. And then the last kind of question I want you to see is, what if I just give you an image like this? If I give you a picture and I tell you, okay, rotate about point G. So start at A. So here's A, here's point G, my center. And I want you to go to 60 degrees counterclockwise. Well, if you notice, they tell you this is 60 degrees, so all of these must be 60 degrees because I have a hexagon. So if I start at point A, and I want to go counterclockwise just 60 degrees, what point do I end up at? B. If I want to go about point G, starting at point D, and I want to go 300 degrees, well, how many 60s is 300 degrees? That's 5 60s. So I have to go 1, Counterclockwise. 1, 2, 3, 4, 5. I ended up at point C. If I want to do this one right here, and I want to rotate point F negative 240 degrees. Now, 240 is 4 negative 60s. And the reason why I keep relating it to 60s because I know that each rotation here is going to be 60 degrees. So each jump is 60 degrees. So I keep asking myself how many 60 degrees is, let's say this example is 240. So then, and you can always just do the division in your calculator. So I need to go 4 negative 60s starting at F. Now negative means clockwise. So 1, 2, 3, 4. I end up at point B. So just make sure you understand the difference between counterclockwise and clockwise, and you understand how to rotate 90 degrees versus 180 degrees versus negative 90 degrees. If you have any questions, you're more than welcome to reach out to me. Have a great day, everybody.